Good afternoon. Let's go and get started. It's great to see all of you on this last day of the conference for the last session. Do you all have a good conference so far? That's great. So let's have some fun on this last session. My name is Sriram Subramanian, and I'm a Senior Program Manager Lead on the Windows Input and Composition team. I've been at Microsoft since 1998 or so, and prior to this release, I've been working on a number of graphics-related features and technologies for the past few Windows releases. Most recently on Direct2D for Windows 8, and before that DirectWrite on Windows 7, and even prior to that on the animation and composition engine for Windows Vista. For this release, I switched gears, and I've been working on input technologies, most notably touch and pen for Windows 8.1, and also the text-to-speech APIs for WinRT that we are going to talk today. From the early days of the PC, sound has been a great enhancer to the user experience. But it was not mainstream. Early PCs needed us to add a sound card to be able to get alerts and notifications and to be able to play games. Today, having sound is taken for granted. Like, we all carry devices or PCs or whatnot, and having sound is something we don't think about. So the next frontier is using realistic human voices to provide a premium experience. So the new text-to-speech API in Windows 8.1 provides opportunities to create new application experiences with natural-sounding voices that you can use to engage the user and differentiate the experience and add value. Here is the agenda for the talk today. First, I'm going to give you an introduction to the text-to-speech functionality in Windows 8.1 and give you some idea of the scenarios that it can help build in your applications. I will use a couple of demos that I will use throughout the talk to help illustrate that. Next, I will discuss the key concepts and the APIs that you can use to take advantage of this functionality in your Windows Store applications. Finally, I will briefly cover the language support and also how you can integrate this functionality with the rest of the platform to implement some advanced scenarios, and also talk about some design considerations to keep in mind. I distinctly remember my own first experience with voice on a PC. This was back when I was in college and I was using AOL Mail, and I heard the distinctive "you have mail" when I got the message. The first time I heard it, it was an amazing experience. Since then, of course, speech synthesis and voice technologies have become much more mainstream, and we all experience it in our own everyday lives. When I get into my car, it's great to have my navigation system take care of the directions. It speaks to me so that I can keep my eyes on the road. When I get to the bank, some of the modern ATM machines talk me through the process of the transaction that I go through. And then we all experience the supermarket check stand, where it's usually a talking computer that is doing the transaction. Of course, the overall experience is not quite perfect. These systems rely on pre-recorded sound files that are stored on these machines, and then they are just played back. And so for us as users, there is limited interactivity, and once the novelty wears off, the experience can sometimes be annoying because of the rigid script. But users are experiencing these every day, and they are ready for speech in their apps and the benefit it brings to them, especially if it adds value to their experience. So there is a big opportunity for you to bring new experience to your users on their Windows devices and applications. We are already starting to see some new apps that emphasize voice to deliver a unique experience. We all have seen ebooks and especially audiobooks available for browsing on the internet, and then you can purchase them. On the Windows 8 store, there is a cool collection of Dr. Seuss apps that implement a voice-first experience. The app allows a child to have the book read to her interactively or autoplay the whole book. And of course, it supports the traditional way of reading as well. TTS will make the development of these apps easier and cheaper by being able to synthesize the speech on the fly. Navigation, as I mentioned, is another application category where voice provides an eyes-free experience for us while on the go. So it's very convenient for me to be able to take a Windows tablet, especially small tablets like the Acer that you all got at the conference, into the car and be able to prop it up and then use the navigation app on that device. Of course, an app like this on Windows can be a lot richer because it can take advantage of other platform services to provide additional value and deliver a better end-to-end experience. For example, a Windows app can take advantage of the other platform services to provide real-time traffic updates or switch the directions based on road work going on. And of course, text-to-speech technology can help reduce the cost of training apps, especially when compared to the alternative of using pre-recorded sound files. Training apps, as you know, will usually have a lot of data to speak out. And so the cost per minute of the recording is going to be significantly less with text-to-speech as compared to a studio recording. It also offers additional flexibility because the app can be modified on the fly, and so when it is time to hit a deadline, you just have to change the text file rather than having to go and re-record the voice. And of course, voice is a great medium to enhance everyday user experiences. Wouldn't it be great if I can get background voice notifications for my most important appointments while I'm doing work on some other application? Assistive technology apps like the Narrator app that does screen reading on Windows is another type of application that takes advantage of this functionality to deliver a good experience for their users. So the possibilities are endless. Ultimately, text-to-speech enables a differentiated experience in your apps to provide more value. And so what that means is that users will be more willing to go ahead and purchase your apps from the store as compared to an app that doesn't have this type of experience. Let's go ahead and see this in action. I have a demo to introduce you to what an application can do with text-to-speech API on Windows 8.1. So let me switch to my demo machine. This is a simple children's book demo application that uses text-to-speech to teach a child about fruits. I can go ahead and click on the name.
Watermelon, cantaloupe, pineapple.
In this, I also implemented some numbers, so a child can learn how these are pronounced.
6, 8, 7.
And of course, because this is a store app, it can leverage other Windows features. So I can go ahead and go to the app bar. So I have some controls that are wired up to the app bar. So I can go ahead and change the voice here. I can change it to a female voice.
Watermelon, cantaloupe, pineapple.
How do you like that voice? So I just found out a few minutes ago that the real person who recorded this voice, her name was Mary Prankster. And so she's a famous actress in New York City. And so it's good to have the story behind the voice. We also have other collection of voices. One of the ones I wanted to play here, because my friend James, who is from England, is back in the room. We have a British female voice. So let's find out how these fruit names are pronounced back in England.
Strawberry, watermelon, orange.
So none of the speech that you heard is pre-recorded. They're all generated on the fly. And the platform includes a collection of high-quality voices that we'll talk about a little bit later. I just showed you 3 of them. So an app like this enables a child to apply all of our 3 of our senses, seeing, touching, and hearing, to be able to have fun and learn at the same time. And for your app, whatever category it might be, having a similar experience could be a good differentiator. Let's go back to the slides. So what you just saw was the text-to-speech API in action. It enables your application to take advantage of the capabilities of the speech synthesizer, built-in voices, and the audio hardware in the device. The built-in voices cover many languages and countries, which means your application and content can reach a global audience. All the voices are designed and tuned to match the nuances of human speech, like intonation, rhythm, and pitch. So you can easily understand the meaning of even long passages of text. What I showed you was relatively short passages, essentially a word. But even if it is long passages, because the voices have been tuned, they can take the context into account and sound very good in books, articles, and news stories. Finally, the API allows the affordance to add bookmarks that you can use to offer finer interactions for your users. So we will talk about that more later. Now that you have heard all about the opportunities and capabilities provided in the platform, let's talk about how you can build this in your application. Everything you need to generate voice output from text is supported by the speech synthesizer object. This is a WinRT object, and it's a core engine for speech synthesis. It can accept plain text or SSML annotated text. SSML is a markup language for speech, which many of you may be familiar with. And it's useful for additional fine-tuning, and we will discuss SSML in more detail. The application can choose to use any of the voices that are included in the system for voice synthesis, and it can switch voices on the fly. The speech synthesizer generates a speech synthesis stream object. This is a strongly typed random access stream that you can then use to play to the user using the system media control, both from HTML or XAML, whichever language you are using to create your application. The advantage of having a stream at your disposal is that the media control and the system together does most of the work after the audio is handed over to that. This means that your application can coexist with other Windows applications that may also have an audio output, and the system will take care of automatically ducking the sound in response to user actions when they switch apps or whatnot. The code to use TTS is fairly straightforward, so let me walk through that next. So let's switch to my demo machine. So the code here is a Visual Studio project here is using the JavaScript grid app template from Visual Studio 2013. The default template gets you started on a store app that navigates amongst grouped items arranged in a grid layout that you saw in the demo. The grid view control works with a data source and a template that you define to convert the data items into their visual representation. So in this case, I am defining my data in this XML file. So I have a group for fruits, and then I have my fruit names, and then I also have an equivalent Spanish name, which I'm going to use later in a demo. And then I have the background image associated with the fruit defined in this format. You, of course, can decide what format of the data suits your application best. And then in my data.js, which is also part of the template, I just have some code to grab the data from the data file and then bind it with the list view items. Let's go ahead and run this. So at this moment, it's not enabled for speech. So I just get the standard list view with the fruit names and all the things you saw in the data file. So you can see I'm touching it here, but there is no voice here. So let's go back and fix that. So first, let me declare the speech synthesizer object. And then I have a line of code here which binds the list view response to a callback function, which I had commented out. And then let's go ahead and call the synthesizer API. So what I'm doing here is that I use the synthesizer object, and then I call the synthesized text to stream async, and I pass in the data, which I have code up here to retrieve it from the list view. And this is the same data that you saw in the data.xml file. And then at that point, I have a stream that I have a marker stream, which I pass it to, which I use it to create a URL blob. And then I just attach the URL to the audio source and then call play. So let's go and run this code.
Watermelon, orange, peach.
So that's all there is to it in terms of creating the adding sound or adding speech synthesis to your application. Just a few lines of code. So now that we can incorporate text-to-speech in the app, let's talk about how you may want to fine-tune the voice to suit the experience. Out of the box, as we saw in the demos, the built-in voices do a very good job. They do that by analyzing the text and the context and modeling the attributes of human speech. Now, what do I mean by attributes of human speech? When we humans talk, we know exactly which word to put emphasis on to convey the meaning, how to control the pitch naturally, and then control the rate at which we talk. We kind of do it instinctively once we learn to talk when we are kids. This attribute of human speech is called prosody. So the speech engine uses sophisticated prosody modeling to make the voices sound really good in a variety of situations. But there are some situations where you may want to tailor it even more. For example, the content may need to reflect the emotional state of the speaker, the presence of irony or sarcasm. And that could use with some tailoring. The other situation is numbers. Numbers are kind of hard to deal with, especially without context. For example, 1-/2 could be the fraction half, or it could be the January 2nd, or in some countries it could be the 2nd of February. So you would use SSML to kind of tweak the output of this. Let's go through some examples to kind of understand where it may make sense to fine-tune the voice output. So switch back to the demo machine. So here I have some SSML samples here. I have a simple demo app. I have a column of edit boxes on the left, and I have the same column on the right. On the left, I have wired it up to play using plain text, and on the right, I have the SSML annotated text. So at the top, let's take just a simple greeting we all do every day.
Have a good day.
So it's doing a pretty good job by default, but then I can control the pitch and the rate to put a little more emphasis on this. So let's hear that.
Have a good day.
So you can notice the difference. I mean, this allows you to tune it slightly. I can, of course, play around with this. Let me see what happens when I change it to extra slow.
Have a good day.
Wow. That almost sounds like Jack Nicholson playing Joker in Batman. Let's go to the next example. So in this case, the pitch also has a contour. So you have fine-tuned that. So that's another way of adjusting it. So the contour here I have on the right is basically allows me to specify the exact values of the pitch through the output audio stream. So the first parameter specifies the percentage into the stream. So 10% into the stream, I want to increase the pitch by 60%. That's what it means by when I say the second parameter is 10% and 60%. 30% into the stream, I want to relatively increase it by another 60%. So let's hear the two streams.
Good morning. Good morning.
So not bad. So let's see.
Good morning.
So it's a little more exciting way of greeting somebody. This becomes more apparent if I try to do it with a slightly longer text.
I am speaking with rising intonation.
That was kind of flat. It was not really rising.
I am speaking with rising intonation.
So after this, the numbers, as I mentioned about before, there are examples where numbers are kind of hard to do, and I have a few examples here. So the first one is 10.20.
10.20.
And this is pretty expected, and the system is doing the right thing. If there is no context, even us, when we look at that number, we'll do the same thing. But what if I want to have it spelled out as a date? And so there is a say as element in SSML that allows me to interpret it as a date. So
October 20th. October 20th.
And I'll go through the remaining examples pretty quickly. So the next one is a number and
1.
But if I want to do it as an ordinal, I have the facility to do that.
First.
The next one is kind of tricky. So the way most of the time the system will do what we expect it to do.
12,345.
That's pretty good. But what if I have an application where I want each of the digits read out?
1, 2, 3, 4, 5.
And finally, I have an example here where I may want to use the break time to be able to break my output. I have a pause, an extra pause. So 3 seconds may be a little too long, so let's reduce it to 1 second.
Press 1 or wait for tone. I didn't hear you. Please repeat.
So I clicked on the left arrow, and then it's just by default, it's pausing between the sentences. So with the break,
press 1 or wait for tone.
I got an
I
extra
didn't
pause.
hear you. Please repeat.
So this kind of break, using the break tone, you can have some code in your application that does something else. Like if the input doesn't come in, it can fire an event or produce some other user action. So the speech synthesis markup language specification, SSML, is a W3C standard that specifies a rich markup language for speech in applications. It provides a standard way to specify properties of speech production like we saw, the pronunciation, volume, pitch, etc. And we support this in the platform. And using this is fairly straightforward. We'll go through the code in a second, but in a nutshell, the speech synthesizer object supports inputting an SSML tagged input text, just like you would do with plain text. And after that point, it generates the speech synthesis stream that you can then use the same code and attach it to the audio element and then play from that point on. Let's walk through the code part of it to kind of see how this is done. So here I have the same grid view based application as a sample as before, but this time I have substituted the fruit photos and fruit names with people photos and names instead of fruits. As you know, like people names are kind of hard to pronounce. My own name is kind of hard to pronounce, so it's a good example of a situation where SSML can be used to fine-tune the spoken output. So let's go ahead and run this app. So right now it's not, I have not annotated it with SSML, so I have photos of some people here, including my own photo. Let's see how it does with my name.
Sriram Subramanian.
Not too bad. So actually by default it did a pretty good job. I am actually happy to hear my name pronounced this way. Let's see, so on the left is Rishiraj Chowdhury, and I think I'm getting closest to how he would like to pronounce it. He's a friend who works with me at Microsoft.
Rishiraj Chowdhury.
Didn't do quite a good job with his first name. Let's see how it does with Jerry Ko, who also works with us at Microsoft.
Jerry KOH.
So in case you didn't hear
Jerry
it,
KOH.
he didn't do such a good job with his last name. Let's see how it does with Uzi, as he likes to go.
Aleksandar Azeluk.
Not too bad. If there are anybody from Serbia in the audience, you can probably tell how good the name was pronounced. So let's go back to the app. So if I take a look here in data.xml where I defined my data set, I now added an SSML element within that. And in this, I am using the SSML phoneme element. The phoneme element indicates the phonetic pronunciation for the contained text. So this is another feature of SSML. So the phonemes here that I specify are based on the International Phonetic Alphabet. So S1 is for string, and it's for the first syllable, and each syllable in the word I have to specify it separately. So in the case of Rishiraj, I have each of the syllables explicitly called out. The dot indicates that there is a syllable break. And then in my code here, I need to declare the SSML header and footer. So let me go ahead and do that. And before I was grabbing the standard plain text data, so let me comment that out. And so instead of that, I'm grabbing the SSML text from the data stream, and I also concatenate that with the header and the footer. And then instead of calling the synthesized text stream here below, which I should comment out, I am now calling the synthesized SSML to stream async. The rest of the code, I left it untouched. So because this one will also generate the marker stream just like it did before. And then from that point, I just use the random access stream to create a URL blob, and then use the audio element to play that. So let's go ahead and run the code. So let's see how it's doing with Rishiraj.
Rishiraj Chowdhury.
Much better.
Rishiraj Chowdhury.
So let's see, let's test it with Jerry's name.
Jericho. Jericho.
I think even Jerry would be proud of this. And then let's see.
Alexandaru Zelaz.
So we did a slight tweak to that. So it just gives you an idea of the flexibility of this to be able to fine-tune the output in these specific situations. So let's talk about languages and voices. Windows 8.1 includes 17 voices covering major markets worldwide. So your voice-enabled applications can reach a global audience. As I mentioned before, all the voices have been tuned in conjunction with the core engine improvements to make sure that they sound human-like and are appropriate to the language and the dialect that they support and can handle a variety of situations. So let's quickly walk through a language demo here. And I just want to quickly show the code behind. The code behind is very, very straightforward. So I just want to, I have bookmarked it here, and so I will just highlight it. I'm not going to insert any code here. So the synthesizer object has a property called all voices. So that's how you will retrieve a list of all the languages that are installed in the system. And then I have some code here to pick up the Spanish title, because I'm going to show a Spanish demo. So I have some boilerplate code here to pick up the Spanish title from the data.xml. And so the only other speech-related function you will call is in response to the user choice in the application, or in your case, it could be hard-coded. You would just call set the voice property on the synthesizer object. So in this case, I just set it to the selected voice. So let's run the app. So in this case, I have all my strings are picked up from the Spanish, so it's a Spanish localized text. There's no translation involved. It's all defined in the data file. And let me select the Spanish voice. Get rid of the app bar.
Sandía. Cantalupo. Naranja. Sandía.
Same thing with the numbers.
4. 6. 4. 5. 7.
So it just gives you the selection of voices give you another way of customizing the app for the intended audience. So we have pretty much covered all the basics of enabling text-to-speech in your applications. As I mentioned before, the TTS API is designed to work well with the rest of the platform. And you can leverage this for some advanced scenarios. One of the situations where it might be helpful is where you need to synchronize the spoken word with what is actually displayed on the screen. A good example of this would be a more advanced version of the children's book demo app that I had, where you may want to actually highlight each word as it is spoken. And this can be extended to all kinds of bookmarking. You may want to do something special after a particular paragraph is spoken. In an interactive test-taking type application, you may want to have a group of buttons acquire focus after the instructions have been read to the user. So in these situations, you can relate specific locations in your input text to actions that are executed on the output stream. So the way to do this is to use the mark element in SSML. You can use the mark element to insert a marker into your input stream. The mark element, unlike all the other elements that we talked about in SSML, is an empty element in the sense that it does not affect the speech output itself. So there's no difference in the quality of the speech output. What it does is that the synthesized stream, the speech engine, will recognize that, and then it will embed the marker in the output stream. And then in your application, you need to register, you write some code for an event handler and register the event handler with the audio element or the media element. And then from that point on, whenever the text is streamed out and spoken through the media element will call the event handler when the engine reaches the marker in the output stream. And at that point, your code will get run, and then whatever you need to do in response to that media element, in response to that event. So here are some design guidelines to consider when you incorporate text-to-speech in your applications. The media controls in both HTML and XAML give you pretty much everything you need to actually play the synthesized voice stream once you get the stream from using the synthesizer object. The media controls are especially helpful for large amounts of content, like in an ebook, for example, because the user will, in that case, will want to pause the book. They may want to fast forward, and they may want to do other things. And so the media controls give you all that for free. So you don't have to write extra code for that. So use them in your applications. As we saw in the demo apps, use the app bar, or if it makes sense, use the charms bar to be able to provide settings for invoking playback or for additional controls. And one of the first things that users will notice about speech in your applications is the voice itself that speaks it. And so allowing them to pick a voice or using a specific voice is an easy way to customize the spoken output of your application if it makes sense. So voice output is a natural enhancement for a broad range of applications, from children's books to productivity applications to games to educational applications. As you design your Windows Store apps, look for ways to use synthesized speech to enhance the user experience. Users perceive voice-enabled applications as a premium experience and are willing to pay for it at the store. With Windows 8.1, we are providing the platform support with the core synthesizer engine and a collection of built-in voices so that it's easy for you to use this functionality from WinRT APIs in your applications. The voices, as I talked about, support a variety of languages and accents, as we saw, so that you can take advantage of it and reach a global audience. I look forward to seeing your voice-enabled apps in the store in the near future. Here are some resources to get more information. The API reference is now online and available on MSDN. So please go and take a look at that. We also have a fairly detailed sample on MSDN as well. So this link will take you there. And if you have any questions, please send them our way. Everybody got that? So this is just a reminder to, after this, to go and evaluate the session. Give me your feedback. So that's all I had. Thank you for coming. Hope you had a great conference, and I hope to see your apps. I'm going to hang out here in the podium area for any questions you may have. So you may want to come up if you have any questions about this or any other topics on the input stack. Thank you once again.